Hey guys, welcome to Chapter 1, Section 4. This section is going to be all on Git, which is it's a type of version control system, as well as Heroku, which is a service where we can have our app hosted and we can deploy our app through them using Git commands. So it's going to be, this section is going to be on that, and then we're going to have a programming section. Not a programming section, but I'm going to show you how to actually deploy the app using Heroku. So if you don't know what Git is, that's fine. We're going to learn the basics here. We're going to learn enough to be able to use it. And what it is, it's just an open source version control system. It was created by Linus Torvalds, who was the creator of Linux. And it's used for all kinds of web applications. It was initially created for Ruby on Rails, but now you can use it supports Java and PHP and a bunch of other languages and frameworks. And what Git was created for is to track apps. It's to track your files and any changes you make in your files from within the app. And it's different from a standard version control system because, for one, it's local. All the changes you make are locally on your computer, and then after you finish making your changes, you just push it to the server, as opposed to a standard VCS. It's just you have your files on your computer and then the remote files, and that's it. There's no middleman. There's nothing else. If you lose your files and that server crashes or something like that, all your stuff's gone. With Git, it takes snapshots of certain content and saves just the changed content, and you can access pretty much you can access the state of your files at any point before you pushed it to the server or after. It tracks everything. I would definitely suggest reading more about Git because it's really handy, and it's something that once you start using, you'll always use it. So and Git was created for speed and efficiency. Like I said, everything's local, which makes it much faster than a standard VCS. Okay, and Git comes with the Rails installer, which is what we already installed a couple sections ago, so you already have it on your machine if you've been following along. So the benefits of Git, in addition to what I just said, speed. Like I said, it's all locally, so there's no network latency or overhead. There's no uploading, downloading, except when you push and pull, which is just done in a single command. So it's very fast. And another benefit of Git is that it's distributed, which means that unlike standard VCS, it doesn't do a checkout of the source code from the server. Like it clones the entire project, the entire repository, onto anyone's system who's connected with the project. So even if you're using centralized workflow, every developer has a backup of the entire server on their local machine. So it's virtually impossible to have it all be destroyed like it could when just having a local and a remote version of the same files. And data assurance. Data assurance is another really big benefit of using Git. Git uses a data model that will ensure integrity of your data. Every file has its own checksum for data retrieval, so this makes it so what you upload is exactly what you get back. So there's no corruption of data. It's almost impossible. Staging is another big thing. Most VCS, most version control systems, they'll have a local version and a version on the server, and that's it. Like I said before, you save the local and then the remote gets saved. That's very simple version control. Git, however, has a staging area, which is a third area in between the local and the remote. Alright, so you can change something and then send it to the staging area without actually committing it to the server. So once you know you're done, you can then choose to commit once you know that you're done editing your files, so it's not actually being uploaded at the same exact time. And the staging feature is actually completely optional. You don't need to use it if you don't want. All you need to do is add an -A on the git command. So you don't have to use it, but it's a really good thing to have. And the next benefit of Git is collaborating with other developers. It's extremely useful to use Git if you're having more than one developer on a project. Like I said earlier, each developer will have their own version on their system. So there's something called branches in Git. You'd have the master branch, which is the master, and then you could create these separate branches off of the master and name those, and then you could just hand that branch to another developer so they can work on it independent of the master files. So they can do what they need to do. Maybe they have a couple tasks, and then they'll upload it, or push rather, to that particular branch, and then the leader of the project or whoever it is can check it out, and then if it looks good, they can merge the branch into the master. So it's very useful for projects that have multiple developers. So here's a graphic from Austeal.com that really depicts the flow, the workflow and the data flow of using Git. You'll see we have our workspace, which is our local machine, and then we have the remote repository, which is Heroku or whatever you're going to use, whatever service. GitHub is another huge name in Git. And then we have the index. This is the staging area between the workspace and the local repository. So I'm going to show you the Git syntax in a few more slides, but for instance, you do git add. Okay, you do an add to add it to the staging or the index or whatever you want to call this. Okay, and you just keep doing the adds for everything that you update, all the files that you're working on. And then when you get that all set, you can then do the commit command, which will send it to the local repository, which is on your local machine. And once you commit everything, you can then push it to the server or the remote repository. Okay, and then you can get it back. You can fetch or pull it from the server, or a new user. It might be a new developer's workspace, and you give them all the control version information for the app, and they can just pull it right from the repository, and then they can work on it. Or they could check out another branch, which this doesn't display branches, but they could have their own branch which would do the same thing. They could add, commit, and push to a certain branch on the remote repository. And then you have commands like diff, which shows the difference between the remote and the local versions. And I mean, there's a lot of commands. I'm not going to get too in depth with Git because it's really, I'm finding it really hard to explain. So I mean, I hope you guys are getting at least the basic structure of it, or the basic idea of what Git is and version control in general. So I mean, that's a really good graphic to show us visually how it works. Now, I probably went over most of this. It's different from other version control systems in that it's local, and branches are easy and fast, which makes it awesome for collaboration. It lets you add content, not files. So it lets you it takes snapshots of changed content as opposed to just uploading files. So it's much more intelligent than a regular or any other kind of version control software. And you never try to integrate remote changes into another state. So everything stays in its place. And again, data assurance. They have strict sets of checksums that they use to retrieve data. So it's virtually impossible to have any kind of bad data corruption. So next I want to go over the Git syntax. I'm not going to go in depth with crazy commands, but there are a few basic ones that we need to actually deploy our app to Heroku, which we're going to be doing next. And the Git syntax is global, no matter what services you're using. If you're using Heroku or GitHub or something else, the syntax of Git is its own. So Git clone is something you would do if you are either coming in a new developer to an existing app, maybe, and you would use the Git clone to actually grab the entire repository and put that on your local system. Okay. Now git init is the initialize command. If you have a local folder where you want to make a repository with the files in it, you would use this command to initialize, and then next you would do git add. Now git add, like I showed you here, puts everything into the staging area. Git add, and you could do git add and then put a file name, but if you use the dot, the period, this will add the entire directory, all your files and folders in the directory, as opposed to having to write every file that you want. Okay, so once you add that to the staging area and you finish doing whatever you're doing, you can then commit it. You can commit to the front of our local repository, which would be here. This is where the commit would bring us. Okay, so there's basically 4 areas. So the commit would bring us to the head, the front of our local area, our local repository. And with every commit, I suggest using the A and the M option. The M, because if you don't use this, if you just do git commit, it'll then take you to another screen where they ask you to enter like comments and information about the commit. But you can just simply add it here, because you shouldn't have to have like paragraphs of information. You just want a comment to just let you know what the commit was about or what you changed. So that's what the M does. It stops that screen. Excuse me. Now the A makes it so that if you delete a file, that syncs up and that it deletes on the remote server. Okay, because if you don't have that in there, it's not going to do that. It's not going to delete a file on the server if you delete it on your local machine, unless you have that. And then finally, after you commit everything that you've changed and you're ready to bring it to the server, you'll use git push, and then master is just the branch. You could push to a different branch if you wanted as well. So if we go back here, you see from here to here, from 3 to 4 is the push. Okay, so it's add, commit, and push, and then you can pull to get it from the repository. And when we use Heroku, when we're ready to push, it's just a tiny change. You just got to have the Heroku. So that's the syntax when we use Heroku. And git checkout just means that you want to switch to a new branch. Okay, so if you have a repository for an app for 1.0 and you want to start building 1.1 or whatever, 1.01, then you could check out and you could go into another branch called whatever the version is, and once you're done with that, you could then merge the branch into the master. So I mean, it's a really good, it's really efficient system for version control. So Heroku, Heroku is pretty difficult to explain. It's because it's one of the first of its kind. Heroku is a cloud platform as a service, which is abbreviated PaaS, and it's a service they sell. It's kind of like web hosting, but it allows you to focus on your apps and not the server, because they do all that. And it can get very, very expensive if you were building a huge app like, say, Twitter or Facebook or sites like that. It can get into the thousands per month, but they do offer an awesome free account for development and testing, and they also give you a 5 megabyte Postgres database, so it's really good for testing and development. You could even leave your app there and just use it as a hosting service as well. But if you're going to plan on getting a lot of traffic or using a lot of resources, it's definitely going to get expensive. But it's a new way of it's a new way of building apps. And like I said, it allows developers to focus on code and not servers and deployment, etc. And Heroku can be scary at first. If you go to the website, it looks really hard to understand, but the gist of it, the basics, it's not that hard, and you'll see that as we go. Now, to implement Heroku, first thing you need to do is sign up for a free account. And in order for us to use Heroku with Windows, we want to download this. It's called the Tool Belt, and it's just it has Git with it. It has some other tools too. I forget exactly what they are, but that's what we'll use with our Windows and Rails installer program. And we're going to set up a database. We're going to use a Postgres database as opposed to the default SQLite, which comes with Rails, because Heroku doesn't support that. It does support MySQL as well, which is what I thought we would use, but it's not. It's a little more difficult. So we're going to use the Postgres database. So we're going to download that in the next video. And then you want to create a repository, and then we're going to push and deploy the app. That's the last thing we're going to do, is actually deploy the app, and we'll actually have a Heroku URL for us to view our app live on the web. So that's it. That was kind of hard to explain. I hope you guys kind of understood what I was talking about, but I think it'll be a lot easier once we actually do this. It's a little harder to explain than to do, so let's move on to the programming part of this section.